Welcome to Calculus. We conquer our fears and flex in the face of adversity. On this episode, Stevenson will demonstrate
So I want to find the second derivative here. This is in your textbook, is on page 176. So the first thing I want to do is do the derivative on both sides. Because this is an implicit function, I'm going to do the derivatives implicitly, which means every y term will generate its own dy dx. So I'm going to have two y terms here. So this is what I have for my first derivative. So what I'm going to do now is I'm going to factor out dy dx and then divide the quantity through. Okay, now I have my dy dx. A little messy, but I cleaned it up as best I could. Now we're going to find the derivative again, but this time we have to use our dy dx. So notice we have quotient rule. Now we could rewrite it and use power rule if you want. It's not as hard necessarily, but let's go ahead and try that. If you want to, if you don't want to and you want to practice your quotient rule, go right ahead. So I can see I have a y term inside. So I am going to use my implicit, so it will generate its own dy dx again, but I do have chain rule here. So I'm going to go ahead and do this derivative, and then I'm going to go from there, or I'm going to pause before I do my substitution. So I did the derivative of the outside. So the outside function is something to the power of -1. So I did power rule. So -1, and then the outside goes to -2 with the inside left alone. Times, now the derivative of the inside, derivative of 1 is 0, but the derivative of y is 1 dy dx. Now remember what I told you, when you do dy dx, this is the key step, we have to go back and go, wait, what is dy dx? And we're going to take this, and we're going to plug it into here. Now it's tempting to leave it like this, but let me show you something. This actually does clean up rather nicely.